Hello everyone, this is Ketish here. In this video, I'm going to go through question number 4 from the AQA 2022 Physics Paper 1 Foundation tier. This question is on the topic of energy. Figure 6 shows a swimmer wearing a wetsuit. The wetsuit helps to keep the swimmer warm. A student wrapped a thermometer in a piece of wetsuit material and placed the thermometer in water containing ice. Figure 7 shows the apparatus. So you have a beaker containing ice, water containing ice, a thermometer which is wrapped in this wetsuit material. So question 4.1, after 30 seconds in the water, the temperature of the thermometer had decreased by 7.5 degrees Celsius. Calculate the average decrease in temperature every second. So if it took 30 seconds for the temperature to go down by 7.5 degrees, how much did the temperature drop every second? To find that, the average decrease in temperature, right, it's usually given delta. Theta is the temperature symbol. That small triangle shows a change in, right? So it dropped by 7.5 degrees and it took 30 seconds. So I'm going to divide it by 30. It will give me, so 7.5 divided by 30 gives me 104, which is 0.25. 0.25 is the answer. So every second the temperature is going down by 0.25 seconds. Next question. The student recorded the temperature of the thermometer after 30 seconds for 4 materials. Each piece of material was the same size and thickness. Now, if they are maintaining the same size and thickness, that is actually, they are controlling that. So that's a control variable. Now, they are recording the temperature for 4 different materials. You got material W, X, Y, and Z. Complete figure 8 using the data in table 4. So you should label the y-axis. They've already labeled the x-axis and they've called it material. So what would be the numbers representing on the y-axis? On the y-axis, you're measuring 2 things, the material and the temperature in degrees Celsius. So the label for the y-axis is the temperature in degrees Celsius. Let me make it slightly bigger. Go, right? So it will be temperature in degrees Celsius. Put that in there. Draw the bars for materials Y and Z. So Y is 16, Z is 12. So you would want to keep the bars exactly the same thickness, only the height is going to change. So Y has to be 16. So if I was to draw a bar 16, it was going to look like that. Now, if you look carefully, let me bring that slightly up, right? If you look carefully, it starts at 0 here, and then the first reading is 5. So each of these boxes is 1. So that's 15, and you need to go 1 more box above 15, and you need to use a ruler to make sure that the lines are actually straight. And Z was 12. So, and 1 mark for the labeling the y-axis and 1 mark for drawing the bars correctly. Question 4.3. Which material is the best thermal insulator? Now, if it's the best thermal insulator, the temperature shouldn't have actually decreased by that much. So if you look in the table again, material Y, the temperature stayed relatively high. So it went from 21 to 16. So it only dropped by 5 degrees. The rest of it actually dropped more. So the best thermal insulator is material X, right? The reason would be because it showed the smallest change in temperature, or you could say the temperature dropped by the least for material Y. Question 4.4. The student tested a new material with a greater thermal conductivity than material Z. Now, tested a new material with greater thermal conductivity. Thermal conductivity is actually the opposite of being an insulator. It's actually conducting the heat better. The piece of new material was the same size and thickness as the piece of material Z. What was the temperature of the thermometer after 30 seconds? Now, after 30 seconds, for material Z, if you look back in the table again, it only dropped to, it decreased from 21 degrees to 12 degrees. So if it was a better thermal conductor, then it should actually be lower or less than 12 degrees. Right? If it was a better insulator, it will be higher. Question 4.5. During the investigation, 0.0150 kilogram of the ice melted. The temperature of the water and ice did not change. The specific latent heat of fusion of ice is 334,000. Calculate the energy needed, and they have given you the equation. Energy to melt the ice equals the mass multiplied by the specific latent heat. So the mass is given here, which is 0.015, 0.0150 multiplied by the specific latent heat, which is 334,000. So using our calculator, 0.0150 multiplied by 334,000 gives me 5,010. So that's 5,010. The student wanted to determine the density of a wetsuit material. The student measured the length of one side of a cube of wetsuit material with a micrometer. Now, a micrometer is a specific device. You probably haven't seen this. We usually use it a lot for A-level, but it's something that is used to measure small lengths, right? And a ruler. The table below shows the results. So using a micrometer, they measured measurement 1, 2, and 3, and they have given you the values. The ruler, they have given you the values as 0.6, 0.6, and 0.6. Complete the sentence. Choose the answer from the box. The results show that compared to the ruler, the micrometer has a higher what? Now, if you look at the micrometer, it goes up to 3 decimal places. Now, if it's going up to 3 decimal places, that means it has a higher resolution. So it has a higher resolution, meaning higher, more detail. Use the physics equation sheet to answer questions 4.0.47 to 4.8. Write the equation that links density, the symbol which looks like a P is called rho, mass M, and volume V. So the equation that links all three of them is density equals the mass divided by the volume. You can write the word equation for 1 mark, or you could simply write the symbol equation rho equals M over V. The student calculated the volume of the cube of wetsuit material to be 0.186. So the volume is 0.186. The density of the cube is 0.3 gram per centimeter cube. Calculate the mass of the cube. So they're asking you to calculate the mass of the cube. Give your answer in grams. So we'll have to use the equation that we wrote on the top. So density is the mass divided by the volume. Write the equation first and then put the numbers in the correct places, which is called substituting. Right? So the density was 0.3 equals the mass divided by the volume, which was 0.186. Now, how do you calculate the mass? You'll have to rearrange the equation. So the mass equals 0.3 multiplied by 0.186. So 0.3 multiplied by 0.186 gives you 0.5, 0.0558, 0.0558 as the answer. So 0.0558. That brings us to the end of question number 4, and I will see you in question number 5.